All right. Good morning, everyone. I hope you're doing good. I'm so happy that this is week two of our learning, and I want to welcome each and every one of us back to class. And I know it's going to be a wonderful week ahead. This week, we're going to be talking Internet Protocol 2, because last week we talked about what? Internet what? Protocol 1. But this week, we're going to be talking about what? Internet what? Protocol 2. In our live class, we're going to be doing a quick revision on what we did last week before we talked about what we'll be doing, before we talk about Internet Protocol 2 for this week. And I hope you are all ready. Please read because I'm going to be asking you some question, some revision question from last week class lesson. So I hope you're ready. So let's change our slide. These are our lesson objectives for this week. And I hope that we're ready. And I want, because this objective must be achieved by each and every one of us. So I hope you're ready for us to achieve what this objective. Now let's start our topic. Talking about what the first part of our topic we're going to be talking about today is what domain name system, which is what DNS, domain name system. And we all know that the primary function of a domain name system is to do what? Is to translate, isn't it? Translate a domain name. Domain name is a text-based name. Example is what? www.facebook.com is a domain name. It's a text-based name. To what? To an IP what? Address. So do you get it now? So the DNS translates what? Our English language, the English that we speak, the domain name, because www.facebook.com is an English language. If you translate into what? Into IP address, what computer understand into an IP address of what the computer what understand. So it stands as a translator between human and computer. For example, if now I'm speaking English, let's say example, I want to communicate with somebody who speaks French who does not hear English. Who do I need? I need a translator, isn't it? They're able to translate my English to French so that the French person can hear me, can understand what I'm saying, and also translate what the French person is saying in English so that we understand what the French person is saying. So the DNS perform such function between what the human and what the computer. And a domain name system which map is a name, it is name domain name system which map domain name to IP what addresses. There was a mapped domain name to what IP address, that it links domain name to their what IP what addresses so that you will know it. Why was this introduced? Was because people cannot. It's difficult for people to memorize numbers, IP addresses as the internet was becoming more was expanding. People find it difficult to recall IP address of a particular homepage and so on and so forth, but they can easily recall what the domain name. So DNS was what created. You know how to translate what this domain name into what into IP addresses. We all know what a server do. What does a server do? It contains what web pages, information, database, video, images, and so on and so forth. That's the function of a server. So a DNS server does what? There are servers that work together to provide IP address for requested what website. And we have four types of what DNS what server, which we are going to be talking about in our next slide. Now, this is how the DNS work. This is a DNS resolver. This is a root domain what name DNS server. This is a what? A top level domain name what server. We call it what TLD server. And this is a what? Authoritative what? Domain name what? Server. Each of this server, you see how you see the line, how this arrow move to this one move to this one, and this one move the arrow to this one send it to the resolver. Resolver will now send it to us when we make a request. Do you get it now? Just if you look at here, this man type was cisco.com to the DNS resolver. The DNS resolver checks through his domain name. It doesn't have what the IP address or the domain name for the IP address for cisco.com, so he could not access the page. He sends it to what? To the root what? Level what? Domain what? Server. This root level server check the extension of what? .com and direct it, assign an IP address to it and direct it to what? To the appropriate what? domain extension on this what, on this top level what, name what, server, which has what, you can store server in dot com, dot net, dot edu, dot ng, and so on and so forth. So he was able to do what, send it to the right what, server on this TLD level, and this will do what, locate what, the, recognize that particular what, extension, and does what, assign an IP address to it and send it to the what, authoritative what, domain server. Then this server will do what will it really do, it will assign the appropriate IP address to the domain name and send it back to the resolver what, uh, resolver what, domain server, and this will send it back to what, to the computer, and it will display on the screen, the .com will display on the screen. So this is just a framework of how the DNS work, but we're going to talk of each and every one of these server in our next slide. Now look at this now. Type of DNS server. We have what? The DNS resolver. We have the root name server. We have the what? We have the top level domain name server. That's the TLD server, and we have the authoritative what, name, domain name what, server. Let's start with the resolver, DNS resolver what, server. It is a server provided by what, ISP. This server is provided by what, by the ISP. It connects the what, the browser of our computer to what, to DNS what, main server. And this DNS main server are three, like I said before: the root main server, the TLD name server. TLD is same thing as what, top level domain name server, and what, authoritative name server. These are the three main server. So the DNS resolver server is like a primary server provided by the ISP. So when you send an information, cisco.com, for it to open the web page, when it's loading, it's checking. If it's not on his domain, he will do what? He will send it to the what? To the next one, to the root name what, server. Then the root name server will perform every other task to others, and so on and so forth, until they will resolve everything and send it back to the what, DNS resolver, and it will not display on our screen, just as I explained in that image in our previous what, slide. The next one is what, root name what, server. There are 13 sets of this server in the world, and they are logically placed in different locations in the world to perform their task. Do you get it now? So this root name server always what, when, for example, let's say we just design a website, was just built and hosted. Now nobody know if somebody wants to, let's say for example, we have a Funlola right at funlola.org dot what, ng. What will happen? This root name server, since we've not accessed this website, this is a new website, and on this Funlola right website, she sells fashion things and baby, fashion clothes for ladies, and clothes for what, for babies, for male, both male and female babies, both boys and girls. But for adults, she sells only female clothes, and this is the first time we are hearing about this particular website. So definitely the DNS resolver server does not have it. So when you send funlolaride.org.ng, the DNS server will check is what, is domain. If it doesn't see it, it will send it to the what, to this root name what, server. This root name server will use the extension .org.ng to do what, to recognize that particular domain name, and do what, assign the appropriate IP address and send it to what, to the appropriate what, extension domain in the TLD what, domain name what, server. In the TLD what, domain name server. The TLD domain server will now also check the extension from its own extension domain, and do what, and assign what, the IP address to it, and send it to what, to the authoritative what, name server. The authoritative name server will now do what, now send the domain name with the right IP address to the DNS resolver server, and the DNS resolver server will not display, send it to us to not display on our screen, the screen of our computer. So the root name server does what? Check what? It check the root zone, the extension of that particular domain name, and he assign the appropriate IP address of the extension domain name, and send it to what? To the TLD name server, which we are going to be talking about on this slide. Now, this TLD name server will do what? stores extension of .com, .net, .in, .edu, .org, .ng, and so many other .in and so on. So he will check there are different domain extension server on this TLD name server. So it will now pick the appropriate one that is related to that extension that the root name server sent to it, and it will now do what? It will now assign the appropriate IP address to it and send it to what? Authoritative what? Name server. This authoritative name server will now do what? Now look at the request and now assign what? The appropriate IP address to that particular what? Domain name, and send it to what? Send it to what? To the DNS what? Resolver what? Server, which will now send it to our computer, and it will now display on our computer screen. So that is these are the types of what? Domain. These are the type of DNS what? Server. Now we're talking about what? Subnet. So subnet is the logical subdivision of an IP address. What do we talk about logical subdivision of an IP address? Breaking down a single IP address into multiple what? IP addresses. What do I say? Breaking down of a single IP address into multiple logical multiple what? IP what? Addresses. So you see, this provides what? The dividing of a network into two or more network called what? Subnetting. So an IP address can be 192.168.0.0. Do you get it now? So now this is an IP address. So subnet is to break down this particular IP address I just mentioned now into multiple into subdivisions of other what? IP addresses. Just like when, for example, let me give an answer. In an IT lab, only one electrical wall outlet is working, and I need to plug 10 what? 10 computers for the practical class which I'm going to hold. What do I do? I'm going to get two extensions that has what? Minimum of at least six ports where you can plug in your socket so that you can charge your this thing. And I will plug one of the extension to the wall outlet and bring out 6 ports. So I will plug 5 system on the outlet on that particular extension with the remaining one, isn't it? Then I will plug the other extension on that one to extend the current again to the extend to another 6 port to plug the remaining 5 ports, the other 5 laptop. That means that I've actually what? Subnetted what? I've already done what? Subnetting to that particular wall outlet. Do you get it now? So that single wall outlet, I've been able to break it into multiple sockets to charge these 10 what? Laptops. So this is what subnetting is all about. So what is the purpose of this subnetting? Is to do what? To relieve what? Network what? Congestion. If you look at it, if you decide to pack everything in one side, will you not be congested? To be congested. So from the example I gave, so this same thing apply to what? To our IP address. So subnetting allows what? To relieve what? Network what? Congestion. Number two, it improve what? Network what? Performance. It improve what? Performance. Do you see now? From the example I gave, was the performance of that or outlet not improved? It was improved from 1 to what? To 10, or should I say to 12, isn't it? So the network was, it improved what? The performance of that particular wall outlet. And the next one is what? It improved network what? Security. It means that if there is an issue with the other extension, the second one I plug, it will not affect what? The first one that I plugged on the wall. Will it? No. Please excuse me. Excuse me. Thank you. It will not. So the same thing in a network. When your network is subnetted, what happens? If one side of the network has an issue, it will be isolated and what? Resolved without affecting the other networks to perform what? Their functions or to communicate with one another. It will not stop it. So that is what this is the purpose of what? Of subnetting. Now we talk about what? Subnet mask. What did I say a subnet mask is? It is used to divide an IP address into two parts. Into what? The host ID and the network what? ID. This subnet mask is used to divide a network, an IP address into two parts: host ID and network ID. So if you look at the table below, I name it what? Default subnet what? Mask. You will see the default, all the default subnet mask here. You are looking at them here. Look at them here. And we have different type of IP address, class A, B, and C. These are different type of IP address, and these are the format of what? Their default subnets, the different subnet what? Mask. The network and what? The node. The node stands is used represents what? The host ID, And this network represents what? The network ID. Likewise, this one here represents what? Network ID. This node here represents what? Host ID. This one here represents what? Network ID. This one represents what? Host what? ID. So you should understand that. Know this at the back of your mind. It is very, very important. These are default subnet masks, especially this one, that of class C. Please note it at the back of your mind. This is the default subnet mask 255.255.255.0, because it's going to help us as we go on in this lesson. Now we're talking about what? Classful interdomain routing. Now look at it. This is binary, this is decimal, and this is what? CIDR. This binary number is decimal is what? Is 0. And this binary number in decimal is what? 128. Do you still remember how we're able to convert binary number to decimal number? When we added those numbers together, we added 1, 2, 4, 8, 16, 32, 64, and 128. Yes, the same thing is happening between this and this. When you check, when you put 1, 2, 4, 8, 16, 32, 64, 128, and the one under it that has 1 and the one we add together, and only one of the this fig on this in this banner, only one here represents what? 1, which is the one of 128, and that's why the decimal here is 128, and we'll call it slash 25. Why do we call it slash 25? Let's go back to our previous slide. If you look at this class C, 255.255.255. How do we get this 255? This 255. It means we added 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64 and what? 120 will give us this 255. We still give us this 255 and still give us this 255. Do you get it now? So that was why we get the slash what? This one for this 0, we get slash what? 24. Because if you look at it, let's go back to the previous slide again. If you look at it, this particular one is 8-bit, isn't it? 111 into 8-bit, add it together, you get this. 111 into 8-bit, add it together, you get this. 111 into 8-bit, add it together, you get this. So 8 plus 8 plus 8 will give you what? 24. So let's go back to our slide, our main slide. Now look, the same thing is applicable to all this and all these slashes. So you get to understand how we got this slash. If you look at this, if you put this particular figure, this one, this 8-bit, into the same 1, 2, 4, 8, 16, 32, 64, 128, you find out that it will be under 64 and what? 128, you have what? This one, isn't it? When you add them together, you get what? 192. This is what? Slash what? 26. Because there are 26 what? Ones. 26 what? Ones. 26 ones. In our next slide, you understand what I'm talking about. Let's go to the next slide. Look at our next slide here. Look at it here. This is slash what? 24, slash 28, 26, 27, 28, 29, and what? Slash 30. And these are the what? These are their decimal. These are what? Their decimal. So we're going to understand it in this place here. Look at it here. Look at this. Before subnetting, this is what? The IP address. This one represents what? The what? The network address. And this one represents what? The host ID. Now, when you now subnet after subnetting, this one still represents the network identifier, but this host ID is broken down into what? Subnet identifier and what? And host what? ID. You can look at it here and you get to do what? Understand it better. If you have question, write it down, note it down. We'll discuss it in our live class. Again, if we are going to calculate our subnet mask, we should be able to know this formula. This formula are important. So these are the things we need to find. If we are performing calculation is subnetting. So we are going to find, we'll be finding subnet mask. We'll find the total number of network, where what? 2 is 2, which is what? 2 raised to power n. N is the number of mask what? Bits. Or should I say ones? Do you get it now? Then for the 3, we are going to look for what? IP addresses on each network. Do you get it now? The total number of IP addresses on the network, which is 2 raised to power y, where y is the number of unmasked what? Bits, or you call it number of what? The zeros. Do you get it now? The next one is what? Total number of hosts on each network, which is what? 2 raised to power y minus 2. We said before, y is what? Number of what? Unmasked bits or zeros. So why do we put this minus 2 here? Why is this minus 2 here? This minus 2 is to subtract what? Number is also have 16. When you do 2 raised to power whatever it is, we'll get this 2 here represent what? Is put aside to represent what? Network ID and broadcast what? ID. What do I say again? Is put aside to do what? To represent what? Network ID and what? Broadcast what? ID. So we get to understand what network ID is and what broadcast what? ID is in our next slide. Now look at this. We want to solve an example now. This is an example given. We are given an IP address of /28, and we're asked to find the subnet mask, the total number of network that can be created, total number of IP address on each network, total number of hosts on each network. Now, the first thing we are going to do is to find the subnet what? Mask, isn't it? And this kind of IP address, like I said before, 192.168.10.c is a class C what? IP address. So if you look at it, /28 from our CIDR table is what? Is 240, isn't it? Is 240. Now look at it now. Look at the look at on your board here. Look at this now, and look at how we've broken this decimal number system into binary number system. 255 is 8 bits of ones. The same 255 again is 8 bits of ones. The same 255 again is 8 bits of what? Of one. And this 240 is what? 4 bits of one and 4 bits of what? Zeros. Remember, if you add all these together, all these ones together, you should get 240. That is 128 plus 64 plus 32 and plus what? Plus 16 will give you 240. 240. When you try to convert this particular binary number into what? Into decimal number, you get what? This 240. And the /28, when you count these ones up to this place, you find out that there are 28 in number. That is why we call it what? /28. I hope you understand it now. That is why we also got the /24, the /25, /26, 27, 28, 29, and 30. So do you understand now? Like I said again, these ones, this 8-bit plus this 8-bit plus this 8-bit will give you 24. Plus this 8-bit plus this 4-bit will give you what? 28. Do you get it now? So that's /28. So our subnet mask is what? 255.255.255. What? 240, because it's /28. Now look at this table. I'm able to put it on this table again so that you see it, and when we add it together, we got what? 240. That 240 appears here as our part of our what? Our subnet what? Mask. The second one we're going to solve is so total number of what? Network to be what? To be created. We use 2 raised to power n. We say n means what? Where n is the number of max bits or ones, isn't it? How many ones do we have here? 1, 2, 3, 4, isn't it? 2 raised to power what? 4, which will give us what? 16 network. 2 times 2, 4 times 2, 8 times 2 is what? 16. Will give us 16 network. We now come down to C, which is what? Total number of IP address on each what? Network, which is 2 raised to power what? Y. Where Y is what? Is a number of unmasked what? Bits or zeros. And how many zeros do we have here? 1, 2, 3, 4, which will give us what? 16 what? IP address will be found on each 16 network. That each network we have what? 16 what? IP addresses. So when you multiply it together, what are you going to get? When you multiply 16 by 16 together, what is the total IP address you are going to get? 16 times 16, what are you going to get? You're going to get what? 256. That is what? 255. Do you get it now? You're going to be getting what? 25 what? 6 what? IP addresses. All right. Now look at this now. So look at this one, the last one. Total number of hosts on each network. That is 2 raised to power y minus what? 2, which is what? 2 raised to power 4 minus what? 2, which will give us what? 14 host addresses. It means these 14 host addresses are the one you are assigned to your 14 computer system on that particular subnet what? Mask. The other 2 are left for what? Like I said before, network ID and broadcast ID. The network ID is to show it will show the it will show the range of what? The range of network on that particular subnet. While the broadcast ID is used to broadcast what? When you want to send a general information to every system, to every computer connect, every host connected to that particular what? Subnet. That is why those 2 are set aside, the network ID and the broadcast what? ID, which is this what? These 2 that we're talking about here. These 2. So these 2 will not be assigned to the computer. They will use on the router for the network and the broadcast what? ID. this particular one. Why this one, this host ID will be assigned to what? To the computer, to the computer what? System, to different computer. That is in total 14 computer system on each what? On each subnet. On each subnet. All right, let's go to our next slide. I hope you understand that. If you have any question, write it down. Then I'll be able to answer it in our live class. So the next thing we are going to do here is this. We're talking about what? Layers of what? Layers of protocols. Layers of protocols. We're talking about what? Layers of protocol. As you can see, this layer of protocol was called, is called what? The OSI model. It's called what? OSI model. OSI model, which is what? Open system interconnection. It is called what? Open system interconnection. So these layers of protocol are of seven, not four as we're seeing here. Four is in our node because they've compressed it together to make sure that, like, they compress it together so that it will become, it will be result into four. And if you look at it, we have the application layer, we have the presentation layer, we have the session layer, we have the transport layer, we have the network layer, we have the data link layer, and the physical link layer. Let me tell you, under the application layer, the presentation and session layer has been compressed into what? Application layer. While that of internet layer is known as, is actually known as what? Network layer. Why this network interface, which we discuss here, is actually known as what? As the physical what? Link what? Layer. If those of us that are going to do networking in the future, we are going to become network engineer, you are going to understand this better, what I'm talking about. But right now, that is the fact, and that is true. But we are going to stick to this because this is what our textbook tells us to what? To stick to for now, because they've compressed each of them into this particular four layers of what? Of protocols. Now we're talking about what? The application layer. We said what? The data is sent by a software program, isn't it? Software program can be an email client, can be a web browser, can be a web browser. Do you get it now? An email client is what? Your gmail.com or yahoo.com or hotmail.com, or your web browser can be what? Your Google Chrome or what? Firefox, your Opera Mini, etc., or your Internet Explorer. Those are what? Your the clients that the application layer makes use of. And on this layer too, this data layer determines the protocol that will be used for both the sender and receiver. You know, if you are sending a mail, you're either using FTP or SMTP. Or if you are sending a, mostly if you are sending a file, you're using what? FTP protocol. If you are browsing, you are using what? HTTP. Do you get it? You're using a web browser. So if you are using an email, you will use what? SMT. You are using what? SMT protocol. SMT protocol is what you are making use of. Do you understand me? What did I say again? You are making use of what? SMT protocol. So it is important that you have that at the back of your mind. So you are using what? SMT protocol. SMT is what? Simple Mail Transportation Transport Protocol. Simple Mail Transport Protocol. That's the protocol an email will use, an email client will use, while a web browser will use what? HTTP. While a file, if you are sending a file will use what? FTP. That is file transfer what? Protocol. So on this level, other protocols are also the Telnet, DHCP, DNS. DNS converts what? A what? And what? A domain name into what? An IP address. We already know already. SNMP, SNMP will also do the same thing. Also, all of them have their own what? Their own function. Do you understand me now? Do you understand? All right. For transport layer, or before we go to transport layer, in this application layer, uh, like I said before, can be of what? Email, can be of virtual terminal, and so on and so forth. So, like I said, the protocol that they use is what? Either they use FTP, they use SMTP, or they use what? HTTP or HTTPS. Do you get it now? Those are the protocols used on this application what? Layer. We're talking about what? Transport layer. On this transport layer use two protocols. Use what? TCP and UDP. What did I say? TCP and UDP. TCP means transmission control protocol. UTP means what? User datagram what? Protocol. Do you get it now? So this layer is controlled by operating system, and it breaks down the data data into what packets. So it's at this layer that what our data is broken into packets, assign numbers and instruction on how they will reassemble. And part of the instruction that is going to contain is going to have what is going to have some the MAC address of the sender and the receiver system, and it will also be put what in a kind of like a frame, or should I say like an envelope. Do you get it now? Like an envelope. It happened also in this particular what layer, but most especially it will happen. The frame will only be completed in the network layer, which is what the internet, the one they call internet what layer. Do you understand me now? So in this internet layer, the IP address of both machine, that is the sending device, the sender device, and the receiving device will do what? The IP address will be what? Will be identified. Both IP address will be attached to each of these packets. Destination from source to what? Destination. The IP address from the source to that of the destination will be also be attached to this what? To this frame, and this frame will be enveloped. Do you get it now? And at this particular level called the internet layer, the port, the port, like I said before, when we talk about network ID and broadcast ID, the network ID and the broadcast ID are attached to a particular port. Do you get it now? So at this layer, they were based on the IP address of the sender and the receiver, the net the internet is able to kind of detect which route or which port is going to use that has this subnet they are going to use to send this particular data out, and the other one will receive it in the other what at the other end. So they also decide the router that particular data packet will do what we follow. It will determine that particular route also. So this happens in this what this layer called the internet layer. Why the network interface, which is to me, I call it what? It's not to me. Normally, it is known as what? The physical link layer. This is where this frame, these packets are converted into bits of what? Of signals. Do you get it now? They are converted into bits of signal, into electrical signal, and or as wave to be sent out into the what? To the internet. Then it gets to the location that is being sent to. So, do you understand this particular part of the layers of protocol? If you have any question, note it down. I will answer you during our live class. So this is what happened. The how information is sent. See the arrow down, the blue arrow down, the green arrow follows into the network. It can be through internet cable, it can be through wireless. Yes, you get it now. Network. Then to now come to the network surface of this recipient. At this point, it will be encrypted here. It will be encrypted here. When it gets, it will not be decrypted to be open, so that the receiver, the recipient here, will able to do what? Will able to read the particular what information or data that is sent to him or her. Now I want you to look at this and ensure that I want you to tell me the layers in burger and what pizza. So you are going to tell me, look at it. We're going to talk about it in our live class. You're going to tell me that. All right. And this is another question again. We have about 4 billion what IPv version 4 addresses. Why is it we have not run out of what IP addresses yet? So you are going to tell me why we have not run out of IP addresses yet, because we have 7 billion population, 7 billion in the world, and the device are more popular every day on the internet. So you will tell me about that in our live class. I hope you enjoy this video. Please listen and summarize it, because I'm going to be asking you questions, and prepare yourself for our next class. I want to thank you very much, and I wish to see you in our next class. So remain blessed and thank you.